Welcome to clickmyproject.com. Discuss about the product. Our product is low leakage TCAM for IP lookup using two-side self-gating. Ternary content addressable memory, that is TCAM, is a popular hardware device for fast routing lookup and attractive solution for applications such as packet forwarding and classification. However, the high cost and power consumption are limiting its popularity and versatility. In this paper, a low leakage power TCAM architecture, which uses two-side self-propagating technique, is proposed to reduce the leakage power dissipation of the mask SRAM cells. The TCAM mask cells are divided into several segments, and the mask bits of one segment are the same except for the boundary segment. In this design, the boundary segment is activated and the others are disabled so that the leakage power can be reduced. The experimental results shows that average 26% leakage power can be reduced by using UMC 90% nanometer CMOS process with 1.0 volt supply voltage when compared with traditional TCAM architecture. With the vigorous advancement of the Internet, the Cloud Service Internet of Things, that is IoT, and IPv6 are widely used in daily life. The router is asked for fast lookup packet delivering path. Content addressable memory, that is CAM, is a high performance search engine, unlike random access memory, which access data based on its address. CAM access data based on its contents. A CAM compares an incoming data with all the words in parallel and returns the address of the best match. The search operation in CAM only spends one clock cycle, but it may spend two or more clock cycles in traditional RAM. The CAM is a fully associative memory, and its memory cell serves two basis functions, namely bit range and bit comparison. These functions can be applied to cache memories and network search engines. A binary CAM stores and searches only zeros and ones. However, binary cannot satisfy the fast commercial application, and the utility of CAM is limited. A TCAM can store and search an additional state called don't care, so that a TCAM can perform partial matching. The TCAM has the ability to find the longest prefix matching for comparing a search data with its cell contents to find all matching prefix and determine the longest prefix in one clock cycle. Here we can see the system flow of our design. So, as we already discussed, our overall design is based on CMOS design methodology. So initially, our core concept comes from CAM, that is content addressable memory. From that we are implementing evaluation logic, mask cells, and as an enhancement of this paper, we are introducing heterogeneous CMOS technology. So heterogeneous CMOS technology is the proposed method, and we may call that as an enhancement of this paper. So as a result of our enhancement design with overall TCAM, we can get power consumption than the previous. Our experimental results will show the comparison between existing and proposed, and it proves our proposed methodology provides better result than the previous methodology in parameters of power consumption.
Timer tool. In timer tool, basically it has lot of sub-devices. That means we are having SID, WD, LED. Like this, we are having separated layout design for waveform designs and for circuit design. So similarly, we are having separate lines for design of separate parameters. So our CMOS design is performed in SID. So our performed design produces the output in WAD. The T-space, that means we can export the code of the designed circuit in T-space. So we can open the code in T-space and we can modify it as our requirement. So we are using SADIC for the circuit design, TADIC for the extra modifications, and WADIC for the output design and analysis of the output waveforms. So this is the tool we are using for here. By clicking this, we can start a new project. So to start every new project, we have to open a new cell. So by clicking the cell, we can design a new circuit design. So in the cell, we can include lot of libraries which consist of transistors, CMOS transistors, resistors, capacitance, such as general devices. So after we designing, we have to set the setup simulation. After that, we have to save the file and we have to execute it. So if we executed the circuit in correct manner, we can get the output in WAD.
Thank you.